Hi, I'm Cassie, and I'm going to walk you through question 17 of the AAMC's official physics question pack. So this question is really simple, again, if you understand the idea of the Doppler effect. So remember I said in one of the previous questions related to passage 3 that the MCAT, they like to test your understanding of a concept by asking about pretty much the same thing in multiple ways. So this is a classic example of that. They're asking about the change in frequency detected at a receiver if two jets, like I pictured right here, are flying right next to each other. So the trick here is that, they give you numbers, right? They give you, one jet's flying at 268 meters per second. And they give you numbers, and so immediately you're thinking, oh shoot, they gave me numbers, the answer choices have numbers, I need some sort of equation, and you start to panic, right? You're like, I don't know what equation I should use, and this looks like the math is gonna be hard. Well, if you get a question like this where an equation doesn't easily come to mind and you're a little bit lost and one of the answer choices is 0, you should always stop to think about the conceptual aspect of the question first before jumping into the math. That's one of the biggest mistakes students make for MCAT questions that have numbers on them, is they jump straight to doing the math before actually considering the concept. So in this case, we have our jets are flying right next to each other. Now, remember we said for the Doppler effect, you need relative motion. So, for example, you need to have one plane flying away from the other plane, or both planes flying in the same direction, but one plane flying much faster than the other plane, right? In this case, the thing that's measuring the wave that's being released is right next to the thing that's releasing the wave. And because of that, there's going to be no change in frequency at all. So this is sort of a trick question. The answer is A, 0 hertz of frequency change. So takeaway here, right, for any questions related to the Doppler effect, you need relative motion for there to be a change between the actual frequency and the perceived frequency, or the actual wavelength and the perceived wavelength. If there's no change in relative motion, if the things are right next to each other, the thing that's emitting the wave is right next to the thing that's measuring the wave, then it's just going to pick up the actual frequency and wavelength of the wave, so there's going to be no difference. So I hope this helps. If it helps, give it a like, and please follow my channel for more content like this.